So hello everyone, in this video we will solve another lead code question, that is number of beautiful subsets. So let us read the problem statement. So you are given an array nums of positive integers and a positive integer k. Now a subset of a nums is beautiful if it does not contain any two integer with an absolute difference equal to k. Now we need to return the number of non-empty beautiful subsets of this array nums. Now then they have given the definition of the subsets. So let us see this first example and understand what the question is saying and try to derive solution out of it. And another thing to notice is that the maximum length of nums can be as max as 20. So let us see this first example and try to derive solution out of it. So this is the first example that they have given, and the number of beautiful subsets are 4. Now what are those beautiful subsets? It is first the individual elements 2, 4, 6, and the next subset is 2, 6. So you can see that either they are containing two elements or one element. So if a subset contains only one element, that will always be beautiful because there are no two elements whose absolute difference is equal to k. So one element subsets are always beautiful. So these are the three beautiful subset, and there is another beautiful subset which is 2, 6. So the absolute difference of 2, 6 is 4, which is not equal to k. So this is one also beautiful subset. Now you can't take 2, 4 because the absolute difference is equal to 2, which is equal to k. So it is not possible. So one thing is for sure, that we need to generate subsets, and by looking at the constraints of the question, we are sure that we can run a backtracking solution. So I'll not show you how to generate the subsets because in the previous video we have already discussed so far. So one thing is for sure, we need to generate subset, but it is not the only thing. There is one more parameter that they have put, or one more constraint that they have put, that no two integers in a particular subset should be having an absolute difference of k. Now what do you mean by that? Now suppose we are currently standing on nums of I. So there shouldn't be any integer which is equal to either nums of I plus k or nums of I minus k. That is what absolute difference is. It should not be containing any element which is either nums of I plus k or nums of I minus k, because in both the case the absolute difference will be k only. So that's why they shouldn't be containing these kind of two elements. So we just need to generate subsets, and the only thing we need to notice is that before adding a particular element to the subset, we just need to check either we have already element with nums of I plus k or nums of I minus k. So how we can do that? We can keep one map of int, which will store the particular number and its frequency. So what we can do, we can keep on adding numbers into our map, and before adding a particular number we can check if there is any number in our map which is equal to these two elements. If it is equal to these two elements, then we don't take that particular nums of I, otherwise we can take it. So it is just a particular variance of that subset problem. Only thing we need to do extra is keep one map and keep storing the elements inside the map. Before storing a particular element into a map, or before taking a particular element into our subset, we just need to check if nums of I plus k is already in our map, or nums of I minus k is already in our map or not. If any one of these is already in a map, we don't take that element, otherwise we take that element and continue. So then there is not much to explain much more about this, because it is just a slight variance of that subset problem. So we can directly now jump onto the code and write the code and understand in a more better way. So let us write the code now. So first thing, we need to declare one map mp, and we'll be doing a backtracking which will return us the number of beautiful subsets. Now also one more thing to notice is that we don't just need to number of beautiful subsets, because we need to do it -1 also. Why -1? Because they have already said that they should not be containing any empty subset. So when we return this backtracking solution, it will contain one subset which will be empty. So we need to remove that subset, because it is given that each and every subset should be a non-empty subset. So that's why we are doing -1 here. So let us give the parameter, and we'll start from indexing 0. So that's why I'm giving 0, and I'll push the map. Now let us write this solve function. So first is the base condition. So what is the base condition? If our I is greater than equal to nums.size, that means we reach the end of the array. So that means we have generated one beautiful subarray or subset, sorry. So after generating a beautiful subset, we need to count that subset into our answer. So we will return 1 because we have generated one beautiful subset. So that's why we are returning 1. Otherwise we have two conditions. We have already seen this in our subset videos or previous videos already, so I'm not explaining much in a deeper way. You can go and watch it out if you want to learn in more deeper way. So one is take condition and one is not take condition. So if we are taking a particular element into our subset, we need to first check if nums of I, that is our current element, minus k is not in our map, as well as nums of I plus k is also not in our map. Then only we can take this particular nums of I, otherwise we don't take this particular element. So if we are taking this nums of I, we need to increment its frequency in our map, and then we need to move forward. So by moving forward, I means we need to go to next index or next element. Now we have another condition, that is not take. So in not take condition, we are not taking any element and we are just moving forward. So nums k comma I plus 1 comma map. Now before moving on to the not take condition, first we need to remove the element, because we are in not take condition, we are not taking a particular element. But if you see here, we have already chosen one element, so first we need to remove it from our map. So after removing, only this not take condition will make any point. Otherwise we have already taken this element into our map, and after this if condition gets over, we are going to not take, but eventually we have taken that element. So before moving on to this not take condition, the element which we have taken, we need to remove it, and by removing I mean decrementing the frequency in our map. And in the end, we need to return the number of beautiful subsets which we have got from this take condition as well as not take condition. So this is it about the code. Let us try to submit if it works on sample test case or not. So yeah, it works. Let us try to submit. So yeah, our code got accepted. Hope you learned from this video. Thank you.